Okay, hello everybody. It's nice to see you all here. So, I'd like to present you a new feature, which is data on MDT, or previously known small file I/O. There was okay. So, what's the current problem with the small files? Usually it's performance, read-write performance. And this is because of all Lastra file system optimized for big file performance. And the way the Lastra is designed, it supposes that there are a number of RPC to OST servers, and that obviously hurts small file performance. And we are going to get rid of it through Data on MDT project. So this project aims to improve this performance by allowing the data for small files to be placed also on metadata server. So we don't need any additional RPC, and all I/O overhead can be eliminated. In terms of this project, what should be implemented? First of all, we need new layout to to identify these files which has data on MDT. Then we need to change client, so it will be able to send I/O requests not only to OSTs, but also to an MDT. And finally, we will need mechanism to perform migration from MDT to OST when files become large. This project, from initial estimations, shows it's quite a big project, and we split it in 3 phases. The first phase is about a basic data on MDT mechanism, just to have it working prototype early. It will not support any auto migration, but migration will be possible through administrative tools, which is LFS, and files could be moved from MDT to OST and back manually. In next phase, we will do auto migration for files which become too large. And after that, we can set a default directory or file system striping to small files striping. Last phase will be about all possible performance optimization. Well, the first in mind, it's read ahead during read zero state. And also we could do optimization detecting first write, which is too big, and avoid the situation when files go firstly on MDT and then immediately should migrate to OST. Also, there is ideas that OST objects can be reserved in advance. So even if file is small, we still could reserve some OST object for it, and that would simplify migration later. It's terms of patterns how files are usually used on one or another system. What are expected benefits? First of all, we review several use cases. It's get utter, open, read write, and usage of read ahead. Let's review each of them. Well, the stat, obviously it will get rid of OST get utter RPC. That's the only improvement here, but it will reduce number of RPC in twice. Open case is consists of 2 two cases. First one is open plus truncate, which can be done only on one server immediately. And the second case, it's not just open, it's open and forwrite. And it's also very optimized because instead of several RPC to different servers, we just have after open, we already can do all locking, read data back, and then we only need to write data. Also, we may read data in advance, even in operations that are not transferring data right now. For example, stat or read dir. If we find out that file is small and its data can be put in reply, so we can immediately return this data back on the client, and it will be completely free. We did some estimations. They are only pure theories. As a basement, there was we done basic operations and measure time for each one, and then just drop operations that will be not needed in case of data on MDT. And you can see that optimizations are quite big. For example, for open operation and written data on at the end of file, it would take almost twice less time. That means, well, instead of, you mean what?
Well, just it doesn't include network latency.
Yes. Almost all these optimizations appears because of we don't need extra network latencies, and we don't need entire RPCs. So you can see the N letter here. It's exactly network latency. So for each RPC, you will have network latency as well as the server time for execution of request. And in our case, we eliminate not only whole operations, but also reduce number of network latencies. Well, despite of these numbers are pure theoretical, we expect the final results will be the same order of magnitude. That's all. Thank you.